Hello everyone. Today I'm here to present on the topic sustainable IT integration. Let me start by introducing myself. I'm Anjali Rachel Anish, guided by Assistant Professor Sanju Sebastian. Since sustainable IT integration is a very vast topic, I'll be focusing on the topic renewable energy integration in data centers. Okay, let's move on to the content slide. The topics I'll be discussing are first, the introduction about my topic, then sustainable and environmental impact, renewable energy basics, understanding the challenges, key technologies, efficiency in data centers, the internal infrastructure of a data center, grid connection, control and monitoring, case studies, challenges and future trends, conclusion, and then references. What are data centers? Data centers are critical facilities that store servers, networking equipment, and storage systems to support various digital services, websites, and applications. Data centers play a crucial role in our modern digital world and are known for their high energy consumption. So, transitioning to renewable energy can help reduce carbon emissions and operational costs. Integrating renewable energy sources into data centers is critical to reducing their environmental impact and increasing sustainability. So let's move on to the next slide. Sustainability and its environmental impact. Sustainability means meeting the needs of today without compromising those of tomorrow. It is essential for addressing global challenges such as climate change, biodiversity loss, resource depletion, and social inequality. Sustainability aims to create a world where humans' well being is not at odds with the health of the planet. This figure shows how we can maintain environmental sustainability. First point is to shift to renewable resources. That is by limiting the consumption of non-renewable resources. Next, protect health of ecosystem. Avoid ecosystems being irritably damaged. Next is to avoid excess pollution. Pollution can cause damage to the health and the Earth's atmosphere. Next, target welfare, not GDP. Value measures of economic and social welfare more than GDP. That is gross domestic production. Next is integrational decisions. Make economic decisions based on long-term consequences. Now, let's talk about basics of renewable energy. That the types of renewable energies are solar energy, wind energy, geothermal energy, biomass energy, hydropower, and tidal wave energy. Now, let's talk about the main challenges faced during the implementation of sustainability into data centers. First is high power consumption. Next, heat management. Then, low server utilization, data center locations, carbon emissions, energy storage, energy costs, renewable energy adoption, and inefficient hardware. The key technologies that we use to implement sustainability into data centers are first is energy generation that we use solar panels, wind turbines, geothermal power plants, hydropower plants. Next, the implementation of smart grids. We have smart meters, advanced distribution management system, that is ADMS. Next, demand response time. Next category is energy storage. We have three types of energy storage. First is battery energy storage. Then we can use flywheel energy storage, pumped hydro storage. Next, implementation of microgrids. Microgrids are small self-contained power grids that can operate independently from the main electrical grids. Microgrids can be used to integrate renewable energy sources into data centers and provide backup power in the event of grid outage. Next is power management and monitoring. Advanced Energy Management System, that is AEMS, can be used in power management. Then also real-time monitoring. Let's talk about the energy efficiency in data centers. there are 9 different strategies that we can use in in implementing energy efficiency in data centers. Data centers consume a significant amount of electricity and contribute to environmental impacts. Data centers can significantly reduce their energy consumption by implementing some of given strategies. First is server virtualization. Utilize server virtualization technologies to consolidate multiple virtual servers into a single physical server. This reduces the number of physical servers in operation, which leads to less energy consumption and improved resource utilization. Next strategy is efficient hardware selection. Choose energy efficient servers, storage devices, and networking equipment. Look for Energy Star certified or other energy efficient equipment that meets your data processing requirements. Next is hot and cold aisle containment. Implement hot and cold aisle containment systems to separate hot and cold airflows. That this minimizes the needs for excessive cooling and reduces cooling related to energy consumption. Next is server room layout. Optimize the layout of servers within data centers to ensure proper airflow and prevent hotspots. Arrange servers in rows with adequate spacing for airflow management. Location and siting. Choose the location of data centers strategically because locating them in region with ample access to energy resources such as so- wind or solar can significantly reduce their carbon footprint. Next is renewable energy procurement. Purchase renewable energy directly from local providers or invest it on-site renewable energy generation. Next is monitoring and analytics. Implement monitoring and analytic tools to track energy consumption and identify areas for improvement. Predictive analytics can help optimize operation. Green building certifications. Aim for green building certification like LEED or BREEAM, which requires adherence to energy efficient design and operational standards. Carbon offsetting. Consider carbon offset programs or invest in carbon reduction projects to compensate for any emissions that cannot be eliminated. These are the main strategies. Uh, Now let's move on to the next slide. So now we are looking at the internal structure of a typical data center. The energy flow, the coolant flow, and the hot air flow, everything. So first on the top we can see utility supply, that is the grid connection, renewable energy production and backup generated um, connected to the primary switchgear, that is ATS. The ATS provides the energy to all the supplies, that is the energy storage and the coolant devices. Now the cooling tower, the chiller, coolant distribution pump and the economizer uh, are used to distribute the cool air into the racks. So the blue dotted line shows the coolant flow and it is distributed into the CREC or CRAH, which then distributes the cold air into the racks to maintain optimal temperature inside the storage. Next, the, these racks contain servers, storage, network devices, and coolant fans. Next, the hot air that is eliminated from the racks are flowed outside. Now the UPS and other energy storage devices that are backups like battery, flywheel, and pumped hydro storage are connected to the PDU and PSU, which supplies the energy into the rack or throughout the data centers. So this is the typical internal structure of a data center. Now let's talk about how the grid connection is implemented into the data centers. Grid connection in data centers with renewable energy is a very complex and important process. It involves various considerations to ensure reliable and sustainable operations. Efforts are being made by industry players to address these challenges and drive the transition to renewable energy in data centers. So let's talk about the processes that grid connection requires. First, first step is to measure, report, and offset. Measure means measuring the energy consumption of the data centers, then report their carbon emissions, then offset their environmental impact through initiatives such as renewable energy credits. Next is design and regulatory framework. Policy makers can design a regulatory framework that encourages systems integration and the use of waste heat, heat pumps, smart heating and cooling system, and energy storage. The third one is power purchase agreements, that is PPAs. Data center operators can enter into PPAs to increase their use of renewable energy. PPAs involve long-term contracts between the data center and renewable energy providers, ensuring a stable supply of clean energy. Next is construction and interconnection. Building and building new clean energy infrastructure involves design, engineering, permitting, constructions, and interconnection to the grid. These steps are essential to ensure the successful integration of renewable energy sources into the data centers. Then next is about control and monitoring. Control and monitoring is essential for ensuring efficient operations, optimizing energy use, and responding to grid connection effectively. The main strategies required for control and monitoring are: first is energy management system, the EMS. Implement a central EMS for real-time control and monitoring. Next is sensors and data collection. Now, uses sensors to collect data on energy usage, generation, and environmental conditions. Then, remote access. We have to enable remote access to the EMS for quick response to anomalies or grid events. That is, if anything happens, uh, any disaster or hazard happens in the data centers, then we will be having remote access to the EMS. Next is load balancing. Optimize energy distribution from renewable sources, grids, and storage system. Next is demand response. Demand response means participate in demand response programs through automated load adjustments. Next is grid interaction. Monitor grid parameters for compliance and safety. Then energy storage, that is manage battery charging and discharging based on grid connection. Then predictive analytics, use of AI for proactive decision making. Alerts and notification. This explains how we can implement alarm system for abnormal conditions inside the data centers. Next is performance monitoring. Analyze data for efficiency improvement and reporting. Next is cybersecurity. Protect systems from cyber attacks. Then integration with renewables. That is sync renewable systems with the data center demand and the grid. Next is maintenance and updates. Regulatory update and maintain monitoring system that comes under maintenance and updates. Now let's move on to the case studies. I have selected a few data centers which runs on 100% renewable energies that are implemented all around the globe. First is Google Data Center in Iowa. Google's data center in Iowa is powered by 100% renewable energy, including solar and wind power. Next is Microsoft's data center in Wyoming. Microsoft's data center in Wyoming is powered by 100% renewable energy, including wind and hydropower. Amazon's data center in California. Amazon's data center in California is powered by 100% renewable energy, including solar and wind power. The data center uses a pumped hydro storage system to store energy from renewable energy sources. So now let's talk about one in India. That is Adani Connex Chennai One Data Center. It is a state-of-art hyperscale data center located in Sipcot IT Park in Chennai, India. The facility offers a range of colocation and cloud services to enterprises and cloud providers. It is the first IGBC platinum rated data center in Tamil Nadu and is powered by up to 100% renewable energy. Now we can talk about the challenges and future trends in our topic. A few of the main challenges faced are intermittency, reliability, grid integration, and data center location. Intermittency and reliability means renewable sources such as solar and wind are intermittent, leading to variations in power generation. That is, we cannot fully be reliable on just solar and wind energy. If any variations in weather, if there are any variations in weather which leads to variation in power generation. So we know that data center require a consistent and reliable power supply, posing a challenge in matching energy demand with renewable energy availability. Next is grid integration. Grid integration talks about integrating renewable energy sources into existing power grids that are already present that are already present in the data centers with present technical challenges, including grid stability issues, and the need for upgrades. Next is location. The availability of renewable energy sources varies based on geographical location. Data centers in regions with limited access to sunlight or inconsistent wind patterns may face difficulties in achieving a reliable and consistent renewable energy supply. Now let's talk about some of the future trends. First is increased adoption of on-site renewable energy generation. Data centers are increasingly installing solar panels, wind turbines, and other renewable energy systems on their own premises to generate electricity directly. Next is development of smart grid technology. Smart grid technologies can be used to manage the variability of renewable energy generation and integrate it into the grid most effectively. This will be essential as the share of renewable energy in the grid continues to flow. Next is blockchain technology. Blockchain technology can be used to track the provenance of renewable energy and ensure the data centers are purchasing the renewable energy they claim to be. This can help to reduce the risk of greenwashing and promote the development of a truly sustainable data center industry. So now let's move on to the conclusion. We know that implementing of renewable energy creates an environmental responsibility among people. Energy efficiency practices combined with renewable energy integration optimize the data center operation. It implements a sustainable leadership. Integrating renewable energy in data centers spikes motivation, leading to more energy efficient hardware, cooling solution, and power management systems. Now let's move on to the references. These are the main references that I have used while studying about this topic. Um, Thank you for your valuable time and consideration. Thank you.